Let's work with differentiation. In this example, as you can see, the function is not written in terms of x. So what? It's still a function. Let's work on the power rule again. I can even write down the power rule for u using u. U raised to the n prime is derivative, gives me n is now multiplied by u raised to the n minus 1 power. Like so. That's called power rule. Remember that. Okay, step solution. Because we see square roots, we don't really like working with square roots as they are. So why not to break this problem into 2 steps as we did before in the previous examples? Let's write down square roots in terms of the powers 1/2. We have a square root of 9, which is already kind of ridiculous because square root of 9 and 3, but fine. We don't have to rewrite this power because power rule is only needed for a function, not for a constant. Thus, this constant has nothing to do to u. It's just multiplied by u. And again, square root of 9 is 3, so I already don't like this example. Plus, what is happening with the square root of 2u? Is it the same thing? Let's carefully understand the notation. Square root of 2 multiplied by u inside of the square root. Thus, I can write it down as square root of 9 times u plus, and check this out, it's going to be square root of 2 multiplied by square root of u. Now I can tell you that square root of 2 is the coefficient just like square root of 9 multiplied by a function. So it's going to be square root of 9 times u plus square root of 2 times u to the 1/2. The first u is raised to the first power, and the second u is raised to the power 1/2. I intentionally did not write square root of 9 as 3 to show you that we have square root of 9 and square root of 2. Both are multiplied by u, and that's it. Now we can differentiate this function. F prime of u is square root of 9 is multiplied by function, so I have to write it down again. Derivative of u is 1. Correct. I hope you did say 1. Remember, it still applies, it still comes from the power rule. U prime is 1. 1 to the u to the 1 multiplied by u to the 0. Plus, square root of 2 is also a rate. It stays there when we differentiate the function. And now I have a new function. U raised to the 1/2 becomes 1/2 u raised to the 1/2 minus 1. We always decrease the power by 1. Final answer will be simplified. Square root of 9 times 1 plus square root of 2 over 2. I collected these coefficients. And u is now raised to the negative 1/2 because 1/2 minus 1 is negative 1/2. This is the final answer. I like it a lot. If you are asked to rewrite the answer with the positive exponents, and also square root of 9 is 3. Let's finally write down 3. Then I will rewrite it as square root of 2 over 2. And now I remember that the negative power sends the u into the denominator, and 1/2 makes a square root out of it. So this is another form of the correct answer. And this comes from the differentiation of the original function, square root of 9 times u plus square root of 2 multiplied by u inside of the square root, like so. Another way of explaining what happened to square root of 2 multiplied by u will be 2 multiplied by u is raised to the 1/2 power together. Thus, based on the properties of powers, it's going to be 2 raised to the 1/2 times u raised to the 1/2. And that's exactly what we have at the end. 2 raised to the 1/2 is square root of 2, and u raised to the 1/2 also is square root of u. We differentiated this simplified version of the original function, and you see the result in front of you. Thank you for watching. Keep working.